Hi folks, Matthew Lanigan here with BayWa RE. I see people are still signing in, so we'll just give it about 2 minutes and we'll come back and get started with our great friends from Fronius. Thank you. Hi folks, Matthew Lanigan here again. I'm the Chief Commercial Officer here with BayWa. Really thank you all for taking your time and to learn a bit more about our great friend Fronius. A couple of housekeeping notes before we get started. This will be recorded. It will be posted up on our YouTube channel. If you haven't applied to the YouTube channel or signed up, we would love it if you did. You can find this webinar as well as all of our past webinars. This will also be shared in the monthly newsletter that'll come out next week. If you have any questions, we will do our best to answer them on the fly. You'll notice there's a box in the bottom right corner where you can put in questions. So would love as many questions as we can get. Continuing education is a really big thing for us here around BayWa, so we're happy to be able to extend that with our customer base today. If I could just have someone test the question box to make sure that it is running accordingly. Great. So without further ado, I'd like to introduce Harsha with Fronius Canada, the Technical Support Manager. Harsha?
Thanks, Matt. Hello, everybody. My name is Harsha, and I work here as a technical support manager at Fronius Canada, where we support folks using Fronius inverters all across Canada. Is everybody able to see my screen?
Yes, we can see it.
Okay, so without much further ado, let's get started. I'll jump right into the presentation. If you do have questions, please feel free to stop me. I prefer to quick questions on the fly. Okay, that's very strange. Come on. Do you see it as a presentation mode?
Just see the big red Fronius front screen.
Okay, so the first slide, okay. And so this is the agenda that I have for you today. Do you see the second slide as well? Okay, something's off. My apologies.
Yeah.
Come on. Sorry, do you see the slide transition or you just see only the first?
No, just the, big red slide at the beginning, Gen24, 208, 240, and retrofits.
Okay. I'm sorry, Emma, could you please, close that and send me the invite again to share it? My apologies, it's taking a little longer.
I did send it through, so you should have got the prompt.
It showed up and disappeared. Do you see it now on screen?
Still the big red screen.
Oh, the prompt disappeared before I could accept it.
I can try sending it through again.
Yes, please. Do you see the next screen as well?
Yes.
Perfect, thank you. My apologies, a few technical snags here, but outside of that, let's just jump right into it. So this is the agenda that I have planned for today. Just walk you through a little bit about Fronius, a little bit about the overview, and then jump right into the Gen24, which is the new inverter that we currently have on the market after quite a big delay, okay? So Fronius is and was and still is a family-owned business. It is currently under the third generation of ownership, and it was started by Gunther Fronius, who's the gentleman you can see up on the circle on the top right side, leaning up against his car. And his expertise was in making electronics for power conversion from AC to DC and the other way around as well. And he started off the business by making an automotive battery charger to charge the batteries that go into cars. And you can see the big one there in the second bubble on the left side with the hood of the car open. And this was all started by him in his garage in 1945 in Pettenbach, that's in Austria, Upper Austria. Okay. Now, the expertise for Fronius is basically in making electronics hardware for power conversion from AC to DC and the other way around. And so it initially started off by making battery chargers, which basically would take AC power coming from the utility, the grid or the hydro connection, and which is AC, and you turn it into DC and use that to charge automotive batteries. Okay. The next, spin-off after that was the Perfect Welding business unit, as we call it. Fronius primarily has 3 business units. The oldest one, which is how the company started, was what we call Perfect Charging, which is basically using electronics hardware to take AC power, convert it into DC, and use that to charge batteries. And the next kind of progression to that was to use the same sort of hardware, except now you would take power from your grid and use that for welding, because it's the same. It's energy conversion hardware as well. And the further, what should I say, segue to that would have been the solar business unit, which we call the SE, or the solar energy business unit, which is the youngest one, which was started in '92. Although the business did start in 1945 with charging, then they kind of slowly entered into the welding market, which is where they made big names for themselves, and then they kind of moved into the solar side of it as well. And if you do pay attention and are able to understand, the common thread between these 3 business units is the electronics hardware, which would basically take power from one form and convert it into the other. And so if you take DC and make it AC, which is what solar does, you'd also be able, required to meet all of the requirements that go with producing such power, because you interface with the grid wherever it goes. And all of our products are made in Central Europe, in Austria. Okay, we've got a few plants in neighboring Hungary as well, but primarily all of our products are made in Central Europe. Okay, now that's the parent company, but the subsidiary is Canadian because we are based out of Canada, and also we do deal with all 3 business units, and we are local, we are diversified, and we've got people working in Canada who are Canadian, and we've got local support as well, including sales. Now, having said that, if you have used Fronius equipment in the past, you would have been very familiar with the IG Plus if you were working in the solar industry, like let's say 10 years ago, which is of a different sort of technology, which we call or refer to as transformer-based technology, wherein you actually have like an actual transformer, like a wire-wound copper transformer on the inside, which separates the AC and the DC sides. Now, back then, that was the technology that was, niche and cutting edge and available on the market. But between then and now, there have been significant changes, and the current inverters on the market do not have transformers in them. In fact, you would barely find any inverters on the market which currently work on transformer-based technology. Okay. Now, after the IG pluses, if you have used Fronius equipment, you would have used either the SIMOs for three-phase applications or the Primos for single-phase applications. Now, both the SIMOs and the Primos are what we refer to as grid following inverters, because were you not to have the grid, the inverter will basically go to sleep because they were not meant to be used in the off-grid mode. And also those were primarily string inverters with no hybrid or storage capabilities on them. Okay, that was all in the past. Now what we've done is the next segue to that is the hybrid inverter, which is the Gen24, which we've launched right now. And you can see a picture of that on the screen as well. Now, previously, the SIMOs went in capacity all the way from 10 kilowatts up to 24 kilowatts and were available for three-phase applications where the grid voltage would have been either 208 or 480. We do not make a 600-volt AC inverter. And that was for the three-phase. And for the single-phase, we had the Primos, which went all the way from 3.8 kilowatts up to 15 kilowatts. And the Primos could work just as well on both 600 volts DC on the array side and also 1000 volts DC on the array side. Okay, so were you to require the Primos for residential applications, you would design such that the array voltage, maximum voltage, even at the lowest temperature, would be under 600 volts DC. And if you were to require that for a commercial application, single phase again, then you could string the array for up to 1000, because for commercial, you can go up to 1000 DC. Okay, this is aside of the requirement for rapid shutdown. Whereas currently what we have now, the Gen24, is not exclusively a string inverter. It is also a hybrid capable inverter. I'll walk you through that in a little bit from now. But in terms of the inverter itself, we call it the Primo Gen24. And we also say 208, 240. 208 does not imply it works for three-phase. It just means it can be used on one leg of a 208 delta system. Okay, because the inverter is a true single-phase inverter. The inverter per se to operate does not need a neutral. That even if you did choose to have a neutral and load the setup with the neutral, the inverter is only monitoring the voltage on the neutral. There is no current on the neutral because the inverter is truly balanced. And on a balanced system, you would not have any current on the neutral. Okay, it's single phase again, so 208 implies just one leg of a three-phase system. Now, it comes in different hardware capacities. There are two frame sizes, as we call them. So the 3.8, 5, and 6 kilowatt power capacities are all of the same physical frame size. Then the next frame size, which is a little larger, is the 7.7 and the 10 kilowatt outputs. Right? For all of these power classes, the input still needs to stay under 600 volts DC. The inverter has 2 MPBTs and 1 battery input, and it is NEMA 4X. Just like the older inverters, it can work up to -40C on the low side and up to a +60C on the high side. Were your temperatures to fall either below -40 or go above 60, the inverter will derate. In the sense, if you went above 60, then the inverter will start dialing down how much power it makes, because it is a function of the internal core temperature of the inverter. And once you cross 60C ambient, that is, not the actual temperature of the inverter, if the ambient touches 60C, then the inverter will start slowly dialing down how much power it puts out so that its internal core temperature does not get too high. On the low side, were you to fall below -40, then the inverter will effectively just go to sleep to protect itself. That's the only thing that will happen. Now, in terms of PV planning flexibility, now this is it's sort of slightly misleading, because you have to remember that when you design a PV array, you per se do not design it for the lowest voltage. Instead, you design it for the highest safe operating voltage for whichever device you choose to work that PV array with. So for our inverters, the max DC voltage on the array side is 600 volts. So ideally, when you design your PV arrays, you always want to choose long strings such that at the lowest temperature you would expect to see at the site, the voltage, despite how long that string is still under 600 volts DC. Okay. Now, having said that, it's not always possible to get long strings, because this is also limited by the amount of roof space you have. Okay, so you got to play it by the ear, because no two sites are the same, no two roofs are the same, and so the installer is the eyes and the ears on the ground. So you play it by the ear. So ideally, what you want to be doing is using the string design tool and then getting your numbers from there in terms of feasible designs and seeing which one of them could be best accommodated on the roof that you think this should be going on if it is a roof mount. Okay, so having said that, the operating voltage range on the DC side is between 800 and 600 volts DC. If you go below 80 volts DC, if you go below 80 volts DC, the inverter will just go to sleep because you just do not have enough power to be able to, what should I say, keep the inverter awake. Now, if you go over 600 volts DC, you'll end up damaging the inverter. So, and since the PV open circuit voltage coming from the array is inversely related with temperature, the lower your temperature goes, the higher the PV voltage, open circuit voltage, and similarly, the higher the temperature goes, the lower the PV open circuit voltage. So you want to keep this in mind when you decide how big you want to go in terms of the number of PV modules per string. Okay. Now, having said that, the inverter has 2 MPPTs, and each MPPT has 2 terminals. And for the smaller frame size, which is a 3.85 and 6 kilowatts, the usable current on the tracker 1 and tracker 2 are not the same. Tracker 1 is a third larger than tracker 2. So which means that tracker 1 is 2/3 of the inverter's capacity, and tracker 2 is 1/3. And the usable maximum current on tracker 1 is 22 amperes, and the usable maximum current on tracker 2 is 12 amperes. Okay, now that is just the usable. Were you to exceed the usable, then the inverter will just clip or saturate. That's the usable, whereas the short circuit is 36 on tracker 1 and 19 on tracker 2. And you always have to make sure that the short circuit array, contribution is lower than these numbers, because if it isn't, it could potentially damage the inverter. That's for the small frame size. And for the big frame size, which is a 7.7 kilowatts and the 10 kilowatts, the inverter's capacity is equally shared across both MPPTs, and both of them have a usable maximum current of 22 amperes each, and the short circuit capacity of tracker 1 is 41.25 amperes, and that of tracker 2 is 36 amperes. Okay, now given that we've got much higher usable current and short circuit current capacity, this should pose no problems when you intend to use this with the new higher powered PV modules which are showing up on the market. Okay, and then we've got 1 battery input to a maximum of 22 amperes. The battery technology that can be used with this model of inverter is the lithium ferrophosphate. Okay, and they're high voltage batteries, not low voltage. And so you cannot use lead acid batteries. And the last parameter you want to keep in mind is the maximum array sizing in relation to the inverter's AC output. We call that the DC to AC ratio, and that is 1.5 or 150%. For example, if you did have a 10 kilowatt output AC inverter, on the AC output side, you have a max of 10 kilowatts, the biggest array in terms of kilowatts you could connect to that inverter is 150%, or 1.5 times 10, which is a 15 kilowatt array, while still making sure that the voltages and the currents for the choice of array you've made is still within the inverter's operational limits. Now, how many of you people have used the Fronius Solar Creator? Now, if you have used Fronius in the past, you would likely be exposed to this. Okay. Now, a lot of people like to use their own softwares, which are very good. But one problem that most third-party software makers, what should I say, have inherently, it's not really a problem. It's actually intentional, and it's correct too. Is they tend to ignore little, what should I say, limitations from the device. Okay. The reason being, if you start throwing all of that in there, whatever output you get from your third-party software is not going to be manufacturer agnostic. And the intention there is you do not want to be biased towards a particular manufacturer. So if you were to do that, then basically you get a certain design, but then we don't really know if that design is really safe to use with a particular manufacturer, simply because the manufacturer's own peculiarities are not programmed into that third-party device. Third-party software. So whatever outputs you get from there, you also want to make sure that that is still safe for the device too, which is why you always want to use the Fronius Solar Creator and plug those numbers in and see if that array configuration is still safe for the inverter, and whether you would actually get what you expect out of that inverter with that particular array. Okay, now in terms of installation and commissioning, if you have worked with the older primos and the simos, you would have had a fair deal of experience in terms of wiring, and how you hook the inverter up in the event that you need the inverter exchange for whatever reason, whether you should or shouldn't have to undo the wires. So if you worked with the primos and the simos, you know that in the event that you need to have an exchange or an RMA, you don't really need to undo and redo your wires. So that's a big hassle and also a lot of non-productive time. So we used to have the snap inverter concept where you've got the mounting bracket, which is passive, no active electronics on it. You've got the connection terminal block and on the bottom half of that mounting bracket. And so the inverter itself kind of swings into the mounting bracket and makes contact. And the inverter is the actual active electronics. So in the event that you were to require an exchange, since everything on the mounting bracket is just like a terminal block with wire connections, it's all passive, that stays. We would send you on a dummy mounting bracket, a replacement power stage as it's called, which is the actual inverter. You would swing out the defective power stage from the mounting bracket on the inverter in the field, make use of the replacement power stage we've sent to you, and make use of the same packaging to send us back the defective power stage from the field. So there's no question of you undoing and redoing your wires, unless of course there was something that got damaged there too, which is usually not that common. Okay, we've kind of carried that concept through here as well. So except here, the mounting bracket is going to be a little different because the mounting bracket here is just only what you see on the first picture on the left. The inverters, what should I say, two parts, the actual inverter, and it comes with a housing shell. So if you were to require an exchange, the shell stays and it's only the inverter that gets exchanged. So we'll send you a replacement inverter on a dummy shell. You take the defective inverter slash power stage off the actual shell there, place it in the dummy that we sent you, make use of the inverter we sent you on a dummy shell in place of your defective power stage or slash inverter. Okay. Now, if you've also paid attention in the past, we did have screw terminals on both the inverter and the terminal block where you would land your wires. And on all Fronius equipment, the use of power tools is strictly forbidden. Not even to undo screws should be using power tools. Okay, and despite multiple modes of instruction and trying to get people to not use power tools, they would end up using power tools under the assumption they'd actually save time, which actually kind of works both against them and against us as well. So what we did was, we didn't want to go through that entire process again because we did absorb a lot of the costs when people damaged inverters, which ideally should have been out of warranty, but in good faith we did go ahead and cover things under warranty, but we could only do so much. So what we did was we changed up the design, and whatever screws were required to be operated at the time of installation, we replaced them all with 180-degree locking screws, or twist nuts as they call. That means is when you get the inverter, it's already fastened. So if you take a Torx T25 and you go counterclockwise half turn, then you basically unfasten whatever you're trying to undo. And once you've finished up whatever you need to do, you want to put it all back together, you put that same T25 and go clockwise a half turn, you basically fastened it. So there's no question of you having to use power tools to save yourself time, because there really isn't much time you will save if you tried doing that. If you tried using a power tool, you'll end up damaging the unit, and that obviously would, right up front, it's out of warranty. That's one thing. Second thing is, on the wiring terminal block on the previous models of inverters, we used to call them the Benedict blocks, and they had screw terminals, and the same issue happened there where people were using impacts and power tools and drills that would end up stripping those screws and damaging it. So, and again, there was so much we could do. So what we did was we kind of, changed up that design. So we've now got these regular terminal blocks, and also you just lift up the orange tab. The opening is ready to receive the wire. You put your stripped wire in there, or the skinned wire, and you push on the tab down, it kind of holds onto the wire. So there's no question of you having to use power tools there either. And once you do that, you will also notice that there was no display on this model of inverter. Okay, that shouldn't be alarming, although some people do find it, a little annoying, if you will. But it's really not that difficult, because pretty much everybody now has a smartphone on them. So what you would do is to activate the access point on the inverter using your finger, because there's an infrared sensor on it, and that will turn on the Fronius Wi-Fi access point. Connect to that with your phone, and when you bring up the app, the Solar Start app, then you're set to. Okay, there's really not much else to it. And also the Solar Start app is a free app. If you choose to, you can go with it. If you don't want to, you can still access the home page via the IP address, which we've kept the same as the older models of inverters. Okay, now in terms of communication, if you have installed Fronius in the past, you would have noticed that we used to have data managers, and not every inverter needed a data manager. So per system, as long as you had fewer than 100 inverters, or the communication cabling that runs between the inverters, were you to add them all up, 1 kilometer is the maximum. Whichever happened first was the limit onto how many inverters you could hook up to one data manager. That was the old concept on the primos and the simos. We don't have that concept anymore. Now what we have is called the pilot, which incorporates both the combinations of the brain of the inverter and the communication together. Okay, there's no separate reservo as it would have been on the primos and the simos. We've combined both the data manager and the reservo and call it a pilot, and every inverter has a pilot now. Okay, so it's got the LED status indications on it. If you want to connect this device to your monitoring, then it's got options for both wired and wireless connections. If you don't want to send the data to Fronius and send it to some destination other than Fronius, you could use the push service. We've also got the API. Outside of that, we've also got Modbus TCP, Modbus RTU. In addition, it's got a whole host of digital inputs and outputs, which you could use to potentially automate the entire system. Okay, so if you've got smart grid ready appliances, you could basically use the IOs from this pilot and use them to drive your smart appliances, and you can basically program the IOs based off of whatever criteria you choose on the inside of the pilot, which is pretty identical to how it was on the data manager. The interface might look different, but the way you'd go about it is the same. Outside of this, there is also a wired shutdown. So in the event that your utility requires that they have remote access to it, you could even provide that to them as well. Hey,
this is a question. Where do you connect the rapid shutdown A and B wires on the inverter?
Okay, so for the rapid shutdown, you need a dry contact. That dry contact does not exist on this inverter. So your A/B inputs will need to be terminated on an external E-stop switch, because that dry contact does not exist on the inverter anymore. Does that answer your question? Okay. So we were talking about efficient energy management. Now, if you have used, excuse me, pardon me. A Fronius smart meter, with the primos or the simos, that could have been performed with the smart meter and the data manager combination are all possible with the pilot and smart meter as well. Okay, so were you to have just the inverter can't tell you how much power it's making.
Harsha, yeah. The gentleman's still asking. Sorry, I did not get that. I have the Gen24 and an RSB Quattro to wire up. So he's asking wiring.
Okay, so you got the signal via A and B. I'll explain how the rapid shutdown box works, and that'll make it more clear. Okay, the box gets its power from the panels that are connected to it on the input, and on the output, it lets out only 28.5 volts DC till the inverter gets a go-ahead signal. And the go-ahead signal is basically the closing of the AB signal contacts. Now, on the previous models of inverters, there was a dry contact on the inverter where you would connect those signal wires on the 3-pin orange terminal block. That's because the moment you had AC power going to that inverter, that dry contact was closed. That dry contact closing would short the AB signal wire, and shorting of the AB signal wire is the go-ahead signal for the box to let that voltage down instead of just letting down only 28.5 volts DC. Now, this model of inverter is sunspec compliant, okay, but at the same time, it's also a hybrid inverter. Now, typically, if you want for rapid shutdown to be triggered through the loss of AC mains, it means that you don't want for the inverter to work when the AC mains are lost. But that is kind of counterintuitive when it comes to a hybrid system, because you want for the inverter to continue producing power when you lose your AC mains, because that's the entire premise on which a hybrid system with storage works, right? So now in this event, if I were to trigger the rapid shutdown due to the loss of AC, the inverter does not have DC being fed to it. So how would it actually power the system or the house continuing? Which is why we don't have that dry contact anymore. So which also means that now if you lose AC mains, the inverter will not automatically initiate rapid shutdown. Okay, and that's intentional because this is a hybrid system or hybrid capable system. You want for the system to continue working. So if I initiate rapid shutdown now, I've disconnected the panels on the roof from the inverter. But how would I work the system as a hybrid if I've disconnected the panels on the roof from the inverter? Which is why we don't have that feature here anymore. And if you want for that feature to be here, or if you want to initiate rapid shutdown, you would have to short the AB signal through an external E-stop switch, because we don't have the shorting of that happening through the dry contact on the inverter anymore. Does that help?
Yeah, thank you.
Okay, thanks. So we were speaking about energy management. Okay, now in terms of energy management, oftentimes when you're working on a system whose primary purpose is to extract as much power as possible from the solar panels and dump it back to the grid, that is usually because you don't have much incentive to do anything else with that energy. Okay, because you're basically being credited for whatever quantity or volume of energy that you are basically exporting to the grid or hydro. Okay, that's one way the system works, but that is kind of dependent on how the market rate is structured. Okay, so supposing your energy rates are very low, then you're more interested in just maximizing the amount of kilowatt hours of or units of energy that you can get from the panel. But that's not always the case. Depending on where you are and how your market rate is structured, there could be different ways you would play this game. Okay, for example, if you were in an area like is common in Europe, where utilities are really not interested in buying energy from you, the idea there for them is to maximize self-consumption. It means that usually, let's assume you're in an area where the grid is saturated. So if the grid is saturated, hydro is really not interested in letting you put on more generation, because it kind of upsets their protection functions. So in those situations, what hydro would be interested in doing is making sure that you make energy, but you consume whatever you make, because they're not really interested in buying. And what they would do in those situations to incentivize you to consume all of the energy you make is to pay you peanuts when you sell to them. Okay, so when you buy from them, they'll probably charge you 20 or 25 euro cents, but you sell back to them, they'll probably give you only 2 or 3 euro cents. So now what does that mean for me? It means there really is no point in me selling energy back to them. I'd rather use that energy to do something else. But how do I do that? That's where the IOs come in. Okay, so supposing, let's assume that you got a regular east-west facing system, and it's a regular 4-person household where probably the adults go to work in the morning and the kids go to school, and there's nobody else at home. Now, but when nobody else is at home during the daytime is the time of the day when the solar production is the most, right? But then there's nobody at home to actually make use of any of that stuff. So what you could do is, if you did have smart grid ready appliances, you could game the IOs such that if you are in a situation where you have production but no load going anywhere, then I can use the IOs to maybe turn on my washer dryer, my hot water heater, my pool pump, or something else like any sort of dump load, etc. Because those are all your own, what should I say, self-consumption, rather than you selling to hydro for nothing. Because later when you work to come back home in the evening and run those appliances, at that time, because the sun's gone down and assuming you got no storage, you'll end up buying from the utility. And I also gave you the example where the utility is going to charge you an arm and a leg when they sell to you, but they really don't want you to sell it back to them, right? So which is why when you're not at home, you could basically automate the system using the IOs to maximize your self-consumption. That's what we mean by saying maximize your self-consumption. And if you were to throw a smart meter into the mix there, then you could basically use that as feedback to make the system even more efficient. Because now you even have a load profile, you know what time of the day you tend to produce more using your smart meter, then you can basically automate the entire system such that these loads turn on at these times if certain criteria are met. Okay, now in terms of the DC to AC oversizing, this is kind of like, what should I say, a slightly different topic depending on where you are. When I say where you are, if you are within the tropics, typically your length of day between the seasons is not all that much. And also how high the sun goes or how low the sun goes, depending on the seasons, there's really not that much difference if you're in the tropics. But the further away you go from the tropics, the variation, the seasonal variation becomes very pronounced, and that affects the solar production. What that means is, if I've got a 10 kilowatt PV array feeding a 10 kilowatt system, there could be a very small part of the year where that 10 kilowatt array could actually give potentially 10 kilowatts to that inverter. Okay, because in summer the sun is way high up, and it also rises much earlier in the day and sets much later in the day. So your solar production during summer could be very good, assuming that the angle of the PV array from the horizontal is the latitude of the place. So then between the equinoxes, you'll have really good production, but outside of the equinoxes, it won't be as great because now the angle's off. In addition, the sun rises much later in the day in the lean season and sets much earlier in the day in the lean season as well. How do we even out our production between these seasons? One way to do that is to have a tracker. Okay, or you can have a seasonally adjustable tilt on the racking, but that's usually more of a ground mount. The easiest way though is to oversize the DC side of the system to the maximum permitted by the inverter manufacturer, which for us is 1.5 or 150%. Okay, that's the idea behind the DC to AC oversizing. Okay, so this is just an example. So this is basically kind of trying to even out the variation in the seasonality. Now the thing is, you might come back and ask me that if I connect, 1.5 times the inverter's rated AC capacity on the DC side, won't that clip for me in summer? Yes, it will. But you also have to keep in mind the reason we suggest doing this is because the cost of solar PV modules is always going down, and the failure rate is very low on a solar PV module, which is why they warranty it for that longer period. And the third thing is there is no active electronics on a solar PV module. So there's very little scope of you having something fail on a PV module. Not to say it won't happen, it could, but typically that's the last thing to fail on a PV solar installation, which is why we recommend maximizing it, because it's really, the price is going down, it's pretty robust, and it's the easiest, simplest way to get the most out of a particular installation. So we always recommend doing that. Now, outside of all of this, all said and done, we cannot prevent shading, clouding, soiling, etc. All of these contribute to reducing the output of the solar panel depending on the angle at which the light hits it. Okay, and also since we do not really control anything, because all of this is decided by the weather, the elements, what's happening at the site, site conditions, etc. The inverter's job is to get you as much power as possible from the solar PV array. And if you have looked at the cut sheet for a PV panel, you would have seen the sort of curve where we say you want to operate the PV panel at the knee, where you get the most power. So the knee is what we call the maximum power point, because were you to operate such that the PV array's voltage and current match that of the PV panel at the knee, then you are actually getting as much power as potentially possible out of that PV array, assuming you've not basically saturated. Okay, because you have to remember, I can get you 15 kilowatts out of a 15 kilowatt array, but if that 15 kilowatt array is connected to a 10 kilowatt inverter, the moment the inverter hits 10K, it's going to stop, because I can't get you anything more, because your inverter is like a throttle, if you will, on what you're getting out of the PV array. But then at the same time, that also means that if I were to connect a 15 kilowatt PV array to a 10 kilowatt inverter, I could potentially get 10 kilowatts out of that PV array rated for 15, even under low light conditions, or when the angle is off. When it comes to angle, I mean, a PV module gives you exactly what it's rated for under STC conditions if the light hits the panel at 90 degrees. And the more you deviate from that 90-degree criteria, the less power you get from it. And since the sun is moving across the sky all the time, we cannot guarantee the 90-degree condition all the time. And to make up for that is also one of the reasons why we oversize it. Now, having said and done all of that, outside of that, you still have to operate the PV array in such a way that you get the most power out of it. That is what we call maximum power point tracking. And the algorithm to do that is what we call the dynamic peak manager. Okay, and the example you see here, if you were to have no sort of shading, soiling, or any other causes for reduction in the power from the PV array, you would be on the blue curve. And the GMPP on the blue curve refers to global maximum power point, which means that there is only one maximum power point on that sort of a curve with no shading on the PV module. And if you were to operate the inverter at that place, assuming it is possible to, then you're getting potentially the most amount of power out of that PV array. Okay, now you have to remember that these curves are actually not static. This is a curve for a particular condition at a particular time during the day. The next time period, it's going to be different because maybe the clouds have moved, the sun also has moved, the angles changed, your neighboring tree is casting shadows, things like that. So which means that this is a sort of playing catch sort of game where that curve keeps moving all over the place, and it's the inverter's job to keep trying to play catch with that. Okay, and if you were to have shading or soiling, then your curve won't be the nice blue curve that you see on the top, the biggest curve there. You might potentially have the red curve with 2 peaks, or black curve with 2 peaks, but even lower than the red curve. And the inverter is basically kind of running across this entire curve all the time in real time, trying to play catch with it. This is basically what we call maximum power point tracking. Okay, now if I were to oversize, then the inverter will saturate at 10K because your PV array could potentially give you 15, but the inverter is going to limit that to 10 anyways, in which case, the moment it touches 10K, it'll stop sweeping the curve till the next period, because this sweep is periodic. It keeps happening at regular intervals. That's how you play catch with that maximum power point. So if you were to enable the maximum power point, which is now currently always enabled by default, then you will get much better output from the system, even when you have less than optimal conditions, which could be like, you got snow on the panels, you've got shading, soiling, cloudy weather, etc., things like that. Okay, now since you have already oversized the PV array and you are going to hit the limit much before, actually hitting the peak, because it's a 10K inverter as an example. And if I've got something more than 10K connected to that inverter on the DC side, the moment the inverter hits the 10K, there's no more sweeping required because that's the inverter's max AC output. I can't really give you more than 10K from a 10K inverter. So the inverter stops there. Now, the advantage to all of this is you do not have to throw on more and more active electronics on the roof, because the roof is the worst place for the electronics, because you're exposed directly to the heat, the cold, the wind, the rain, everything. Now, all of those are basically factors that contribute to the aging of electronics. So ideally, we would not recommend that you put electronics on the roof, because that's the worst condition under which you can potentially operate electronics, which is why we kind of do not believe in the philosophy of micro electronics or module level power electronics, which go up there on the roof. We'd rather have all of the electronics at a central place, which is why we believe in the philosophy of string inverters, because all of the electronics is concentrated in one place. Okay, these are different reasons why you could have, less than optimal production, and were you to include the dynamic peak manager, then even the hashed area in the curve will be covered. Excuse me. Now, outside of this, Fronius strongly believes only in active cooling. Different manufacturers, pardon me, follow different methods of cooling. Some people follow passive cooling. Passive cooling means you've got no fans, you've got no moving parts helping with the cooling. It's just one big heat sink, okay? And you're counting on the design of the heat sink and the size of the heat sink and how well it handles the heat to be able to radiate all of that heat out and keep the electronics at a certain working temperature. Now, typically, passively cooled systems tend to operate at a slightly higher temperature than actively cooled systems. And for electronics, the cooler you keep it, the better it is. Now, the common refrain would be that active electronics have moving parts, so the failure rate is higher, but that typically is more a function of how well you are sourcing your cooling or moving parts, which is the fan. So typically, if you are able to source quality components, your failure rates would be low, which is what we've been experiencing as well. And also, actively cooled systems have their electronics working at lower temperatures than passively cooled systems, and typically electronics gives you better performance and longer life the cooler they are kept. Okay, now outside of all of this, the single biggest difference between the Gen24 and the previous versions is that the Gen24 is a hybrid or hybrid-ready inverter. Okay, what that means is the Gen24 comes in two kinds. You can buy the Gen24 Plus, which is hybrid-ready out of the box, or you can buy the inverter as just a hybrid string inverter. Okay, but the hardware on a string inverter, the Gen24 without the Plus, is the same as the hardware on the Gen24 Plus as well. The only difference is the Gen24 Plus comes with the software already pre-installed on the inverter so that you can work it as a hybrid inverter out of the box as long as you got your own batteries. Whereas a Gen24, just a plain Gen24 without the Plus is not a hybrid inverter, okay? And so were you to lose the grid, you got no batteries, effectively you would expect for the inverter to turn off. But we have a feature which we call the PV point. Okay, so this is not to be connected to your AC power board. So the moment you lose hydro or the grid, the inverter is going to turn off when, in the sense, on its AC output terminals. But this point is a separate 120 volt terminal, which you cannot wire to your AC power board because that's a violation of code. You have to wire this to a separate receptacle. And the moment you lose hydro, assuming it's daytime and you got in a light, that receptacle is active. Okay, it's only 120 AC, not 240. Okay, and it's not per se meant to be running heavy loads. It's more like an emergency backup solution because it can only give you 1.5 kilowatts continuous and 2.5 kilowatts in rush for about 5 seconds only. Okay, and the moment your utility comes back, this will automatically switch off. You don't need to do anything. Okay, now ideally it's already current limited, which means that if I take the output of the disturbance and short it on itself, the inverter will just reset. Okay, so which means that even if I were to throw some sort of protection, either fuse or a circuit breaker there, it might look like it's doing something, but it really won't because the inverter itself would have shut off to reset if you were to create a short there, even before your fuse blew or your circuit breaker tripped. Okay, so just keep that in mind. And also it's very simple and easy because you aren't permitted to connect this back to your AC panel board. You should not. That's a violation of code. Your ESA inspector will also give you grief if you tried that, which is why we say you should wire this only into separate receptacle. If required, you can throw in a circuit breaker or a switch or a fuse as well. Okay. Now, in terms of service, I already kind of told you that you don't really have to undo and redo your wires. So you just take only the power stage off in the event that you need an exchange. It's also very easy to troubleshoot because we kind of kept all of the components right up front. Okay, and if you have troubleshoot with us, having called it in before, it's pretty much the same way you would go through, except we made it even easier. Okay, and you don't need to replace the whole inverter, which means you do not have to undo and redo your wires, all of that stuff. You just swing the power stage out and replace it with the replacement power stage we sent over. Okay, and it's also got pretty good efficiency. It's about higher than 97%. Service is real easy because you're not spending any time or money or effort on wiring and basically taking off the wires and putting them back in. Okay, and also Fronius believes very strongly in reduce, reuse, recycle in terms of the sustainability point of view, and all of the aluminum that's being used on that model of inverter is recycled. Now that's all the spiel when it came to the string inverter side of the business, but I did tell you that this inverter is a hybrid capable inverter or a hybrid inverter, and this current inverter currently, we are working on making it compatible with more than just one manufacturer. Pardon me, give me a second, please. Sorry about that. So we are working on making this compatible with more than one model of battery or battery manufacturer, but for now it is compatible with the BYD HVM, and these are the different power capacities that it can work with. So it is a DC coupled battery system, not AC coupled, and also it is lithium ferrophosphate, and it's high voltage, not low voltage. So the inverter cannot work with 48 volts on the DC side, and it is not going to work with the lead acid battery because it's only meant to be used with lithium ferrophosphate batteries. Okay, now there's different ways you can walk the system in the event that you have an outage. Okay, let's assume that you've got an existing Primo-based system, the old school Primos, which are not capable of working with batteries. So you might want to, let's say that you want to expand your system and also include storage at the same time. Then what you could do is either remove the old Primo or keep the old Primo and build a new PV array and throw in this one as well, so that when you lose the grid, because this inverter is hybrid, it won't shut off, but it'll make you the grid. Whereas the old Primos were exclusively grid following or grid tied, which meant that the old Primos, were they to lose the grid, the inverter will basically shut down. Whereas now, the Gen24 is not grid tied, exclusively grid tied or grid following, because it is a hybrid inverter. So which meant that when you lose the grid or hydro, the Gen24 can make you a grid, and that grid phase is good enough to keep the old Primos running. Okay, so that way you can effectively work the system like an AC coupled system or a small microgrid were you to lose hydro. And the moment the utility or the grid or hydro came back, then it goes back to working as if it's a grid tied system. Okay, so we call that multi-flow technology, and you can choose to program the system such that the battery discharges into the loads or to the grid. You can program it such that the battery only charges from solar or from grids. Again, it depends on how you want to play with it, but all of those options are possible here. Okay, that's as far as for the Gen24 I had planned for today. Now, outside of that, one other thing that's very, very important when it comes to the solar industry is your PV modules, PV array, etc., are usually warranted for 20 or 30 years, whereas your inverter is typically only ever warranted for 10 years. So which means that it is highly likely that you will end up replacing the inverter before having to replace the PV array in its entirety. Okay, because your inverter's got a shorter lifetime because it's active electronics compared to the passive electronics that go on the PV panel or the PV module themselves. And that process of replacing only the inverter on an existing old PV array is what we call as retrofits. Okay, and there's different reasons you would choose to retrofit an older PV array with a newer inverter. These are a few different reasons. One is your warranty on the existing inverter could have expired, because typically inverters are only warranted for 10, 15, 20 or more years, whereas your PV array without any sort of warranty extension is typically warranted for anywhere between 20 and 30 years. Okay, it is possible that the manufacturer of the inverter is no longer in the market market or serving that particular market, or the manufacturer of that particular make of inverter is not able to support you with parts or spares to replace inverters and reduce your downtime. It could be that you suspect that the system is aged and you're not particularly happy with the performance, and to counter or to hedge against performance degradation, you might choose to basically put in a new inverter, or you might completely want to tear the entire system down and rebuild it. And when you do that, it's highly likely that you will choose to go with a newer inverter than an older one. So these are different reasons why you could choose to retrofit an existing PV array with a newer inverter. Now, it is not always possible for you to get the exact same model or the same sort of inverter with the same exact parameter matches for what you're pulling out as what you choose to stick in there, right? So for that, there's a few different considerations you need to keep in mind. That's what we will cover here. So one thing you want to keep in mind is how old is your system and what were the requirements in terms of the maximum limitation on DC design voltage back then versus what's available now. Okay, I'll give you an example. If you are from Ontario and you were a part of the Fit One, solar, what should I say, gold rush, if you will, then back then all of the PV array designs were limited to 600 volts on the DC side, whereas now that is not such a limitation. Okay, now it's only 600 if it's a residential rooftop. Outside of that, you can pretty much go as high as you want, as long as it's under 1,000. Although I do know that some countries are moving it to 1,500 as well. Okay, that's one thing you want to keep in mind. Second thing is, what is your grid voltage? Okay, on the AC side, is it single phase? Is it three phase? If it's three phase, is it 208? Is it 480? Is it 600? The inverter that you're pulling out, what voltage is it? 208, 480, 600, or 240? The inverter that you plan and putting in place, or what you're pulling out, is that really rated for the same AC voltage? If it is not, how are you going to interface or bridge this gap? Are you going to be using a transformer? If you are going to be using a transformer, do you need a neutral? Do you not need a neutral? All of these are different considerations that go into that design. Okay. And then the next thing is the rated power of the unit. So maybe you're pulling out a 33 kilowatt inverter. Do you really have a 33 kilowatt inverter meeting all of the previous requirements we just spoke about that is currently available in the market? If it isn't, then what are you going to do? Are you going to derate it, or are you going to get a much bigger unit and do something else with it? So that is called the rated power of the unit. And whatever you are going to be doing with that, is that something that ESA is going to buy? Okay, all of these things have to be kept in mind when you are going through the exercise of retrofitting an older PV array with a newer inverter. Outside of this, there are basic technology limitations itself. So if it's a 10 or 15-year-old PV array, it is highly likely that the model of inverter that went on that sort of PV array is of an older technology, which is what we call transformer-based technology, and that typically works only with what we call grounded PV arrays. So PV arrays are basically like, what should I say? You got a positive lead and a negative lead. Neither positive nor negative is actually bonded to ground anywhere on the array. Whereas when you bring it into the inverter, if you were working on the old style transformer-based inverters, the one polarity of that PV array is bonded to ground inside the inverter. Okay, now, so that is what we call a grounded array or a bonded array. And that technology is different and it's old school. Currently, there are pretty much no manufacturers on the market who are offering that model of inverter, which means you will be stuck with having to basically put in a transformer-less inverter, which comes with its own advantages and disadvantages, and try to stick that in place of an older transformer-based inverter, which had its own peculiarities as well. Okay, and there's certain thumb rules, checks and balances you will have to go through when you are going through that exercise, because if you didn't, you could potentially end up damaging the new inverter because you didn't do due diligence. Outside of this, what is your DC to AC ratio? Because back in the day, a lot of systems were built with DC to AC ratios of almost 2, because you wanted to get as much power as possible out of that PV array. Whereas now inverter manufacturers have started clamping down on how high you can go on that DC to AC ratio. How does that fit in with your calculations? Rapid shutdown. Do you need rapid shutdown? Do you not need rapid shutdown? Are you going to be grandfathered in, or are you going to be forced to comply with the latest rule at the time of retrofits? Now, outside of this, the balance of system components, how good are they? Have they degraded? Do you need to do anything there? Are they checks and balances to check for how badly they have or have not degraded? Monitoring. Do you have monitoring? Did you have monitoring previously? If you did or did not, it's always good to have monitoring on it going forward, because monitoring is not just fancy bells and whistles, it's actually a live health record for your system. And if you know how to read those logs, you can actually predict how the system's going to fail or when the system's going to fail, or what you could potentially do to prevent it going down that way. Okay, outside of all of this, you have other specific requirements from the authority having jurisdiction who might weigh in when the system is being built, and you unfortunately will have to comply with those as well. Okay, that's pretty much what I had planned for today. If you do have any questions, I'm we could have them now.
Harsha, we do have one. I don't understand what components would have to be involved to get the Gen24 wired as straight grid tie inverter changed into a Gen24 Plus. Can you please elaborate?
See, I'll give you a little bit of background as to how a system would work if you want for it to work as a battery backup system when hydro is down. Okay, when hydro is down, whatever loads you've got in the house, etc., is still connected to your panel board, and effectively your panel board is still connected physically to hydro because no circuit breakers have opened, no switches have opened. Now, in this condition, if you start producing power, you could potentially feed power back to hydro, and if somebody is working on the lines there, you run the risk of electrocuting them. So one basic requirement is, if you want to work the system as a hybrid system, when hydro is down, you have to sort of island yourself so that you don't end up putting power back on hydro's wires. Now, you need a piece of equipment, so that's usually kind of akin to an automatic transfer switch, if you will, which is also smart at the same time. We call that the essential load backup unit, which is going to be released sometime this year, which is currently undergoing test. That is one piece of equipment that you will need if you choose to work the system as a hybrid Gen24 Plus based system. This is in addition to having your own batteries. You still need that for storage. Does that answer your question?
Yes, thank you.
Okay.
Great. Well, I don't see any more questions. If any of you have questions, please reach out to your outside sales reps. They're well versed at Fronius. They'll definitely be able to help. Thank you again, Harsha. Really appreciate you taking the time to be with us. Thank you, installers. Really appreciate it. This was recorded. It'll be on our YouTube channel very shortly. If you haven't signed up for the web shop yet, I would highly encourage you to. It's an extremely powerful tool to extend, us being part of your procurement team. You can see specs, pricing, inventory, install manuals, previous orders, many powerful tools in there. And once again, thank you, everybody. Really appreciate the time. Hope you all have a great rest of your day.
Thanks, Matt, and thanks for having us.
Take care.
Take care. Thanks. Bye-bye.